Oh, yeah, right. Cool. So I'm excited to introduce our third seminar speaker today. It's Dr. Matt Brownlee. He was my master's advisor way back, I guess, six years ago, I think. It's great. He was one of Clemson's best and brightest. Professor of Parks and Conservation in the Department of Parks, Recreation, and Tourism Management here at Clemson, where his interdisciplinary research links outdoor recreation, park planning, and resource management. Dr. Brownlee specializes in research design and analytical methods, specifically related to applied social science research in parks and protected areas. His research supplies information to help natural resource managers characterize and evaluate human-nature interactions, including A, park visitor behavior, visitation estimation, and visitor capacity; B, people's interactions with and attachments to climate-sensitive and climate-impacted environments; and C, linkages within dynamic and environmental social systems. Matt has current or past projects with several state agencies, as well as pretty much every federal agency that there is. He has presented or co-presented more than 150 times at international and regional conferences, and has authored or co-authored more than 120 peer-reviewed journal articles and technical reports. One of Matt's greatest joys is working closely with graduate and undergraduate students through applied research, where they work collaboratively to address the critical management need in addition to understanding or unanswered academic questions. When not conducting research or teaching, Matt loves spending time with his wife and 2 children. He enjoys camping, hunting, fishing, traveling, and community events, including, of course, Clemson football. That, let's welcome Dr. Matt.
Hopefully that's a good Clemson football watching experience this week. What that introduction really means is that I'm old, right? I got a lot of wrinkles on my forehead, probably got B minuses in my term papers, but A's on my group work. And so that's what's landed me here. Being a professor is kind of like doing term papers for life, right? So I'm here to talk to you today about digital mobility data and the role that digital mobility data plays in visitation estimation. So I'll give you a preview here of where we're going, but before I do that, I want to talk a little bit about the Park Solutions Lab. You can get on our site and poke around and kind of see what kind of projects we're involved in and the collaborators that we have. But we're an interdisciplinary group within the Clemson University Institute for Parks. We do a lot of partnerships with our federal agencies, kind of the usual suspects you see there: Forest Service, Fish and Wildlife, BLM, and Park Service. And we're really management centric. So we start with a management problem. We build a research design around that in order to address a management issue. And then we dabble in interesting academic questions into that, new metrics and measurements. And that's what we publish from. So we focus on visitor use monitoring and estimation, human nature interactions, including wildlife, and then use that information for conservation planning and support. Definitely, as many labs that y'all are involved in, we use it as a training ground for postdocs and graduate students and some undergrads. And I come bearing gifts today. Everybody gets a Park Solutions Lab sticker. You can pass those out and then post it in your favorite sticker spot. I mean, cooler or water bottle or whatever. So where are we going today? Well, I want to provide some background material to start out with, and that background material is going to be around visitor estimation, what it is, why it's challenging, what managers think about it, what do we know about visitation estimation from the literature, and then we're going to dive into digital mobility data. That's one mechanism for visitation estimation. Following that, I'm going to have 2 case studies, one fairly local here in South Carolina, and a smaller scale, kind of keep things simple. And then we're going to advance that nationwide and look at another case study, another research project at the national scale with Fish and Wildlife Service. Of course, I'll end with practical recommendations, research directions, and then conclusions. So let's start with a key definition for today, probably something that you've been aware of in concept, maybe not attached to the academic mumbo jumbo. But visitation estimation is essentially taking raw data counts, field estimates, and then adjusting those raw counts in unique ways in order to approximate human use in any kind of park or protected area, or within particular zones within a park or a protected area. And as the name implies, visitation estimation is an approximation, which means that there's error somewhere in that approximation. And the goal is to reduce that error while maintaining or increasing the consistency of the monitoring. So although a relatively simple question, how many people visit this place? It's actually not just an interesting question to answer, it's foundational to management. And it informs staffing, it informs budgets. There's legal requirements for many parks and protected areas to set visitor capacity limits. So it helps in that planning. And then it also helps with kind of broader analyses like economic analysis for expenditures in and near protected areas. All of those kind of things use visitor estimation data in order to leverage or to produce larger results. It provides credible, defensible information for conservation and policy, and it's legally required by some foundational legislation in 1965, and more recently in 2025 by the Explore Act, which further requires specifically federal agencies to ramp up their visitation estimation in form of accuracy and reliability. Traditional approaches, things that you're probably familiar with when you think about visitation estimation, things like vehicle counters. We've all probably been to a protected area before where there's a black magnetic tube across the road or a magnetometer sitting over to the side, traffic counters, GPS loggers, field cameras, and the raw counts from that, often there's multipliers or conversion factors applied to that. And in the simplest example, you can think about if a vehicle counter registers a vehicle going by a specific location, then a multiplier of 2.3 people per vehicle might be applied to that in order to go from a vehicle count to a human count. So a variety of multipliers or conversion factors. The efficacy of different approaches and equipment depends on context. You can imagine that calculating visitation in a large, porous, remote protected area might require different methods and different multipliers, different equipment than we would see at a closed unit like Army Corps of Engineers site like Twin Lakes Campground that we have here close. And because of that, managers often need to combine multiple methods, right? It makes sense, it's logical. So there's a variety of methods that get combined in unique ways in order to do the best estimation possible. If you're interested in visitation estimation, particularly at the federal level and what our federal land management agencies are doing for visitor estimation, download this report. It's pretty recent, 2025. It catalogs the different estimation approaches, the different equipment, different definitions used by agencies, and it delves a little bit into some of the protocols used by those agencies to convert the raw data count to a visitation estimation. But visitation estimation, although the question is simple, how many people visit this place under what conditions, it's extremely challenging to get to that answer. And it's challenging for a variety of factors, right? We have a bunch of different methods that can be employed, a lot of different types of data sources that can be used. A lot of times those have specialized equipment and associated protocols. Coming up with reliable conversion factors, that 2.3 person per vehicle might work 85% of the time, but what about busy holiday weekends and other things like that? And so those conversion factors sometimes are difficult to find reliable estimates for. The visitation estimation is particularly challenging for large, remote, porous protected areas with multiple access points. And then, of course, as you might imagine, limited staff at places like refuges and state parks and other protected areas, and the actual direct costs of doing good visitation estimation sometimes hampers the accuracy. All methods, as a reminder, are an approximation, and there's inherent trade-offs there, cost and complexity. In 2024, we finished a four-year project with Fish and Wildlife Service. And at the Park Solutions Lab, we're not really necessarily in the business of counting visitors. We do that maybe as a requirement if we're working on a large capacity project, but we don't generally get contracted out just to count visitors. We partner with agencies and visitor estimation projects in order to help them revamp their estimation system. And that was what we did here in this project with Fish and Wildlife Service. And as part of that, the pretty complex project, but part of that project, we wanted to interview managers. And we wanted to hear about what are the challenges, barriers, constraints, and successes from managers' perspectives. And the intent wasn't to have a representative sample of managers. It was to leverage information from managers who were most involved in visitor estimation for Fish and Wildlife Service. So we ended up with about 10 hours of interview data. From that, we were able to distill some themes like credibility issues in the data, resource constraint, training gaps, a lack of standardization across different refuges, and some challenges with comparability. Managers also said that there was actually some pretty decent organizational alignment across agency levels, but in other areas it fell short. And without trust, even reliable data goes unused. That publication's in review, but if you're really interested in the outcome of that interview, you can send me an email and I can share that document with you. As part of that project, we also did a large literature review, over 2,000 sources. We whittled that back using several criteria to 135 documents. And we use those documents to identify some themes in the literature. These will not be surprising to you. All methods have benefits and shortcomings, and good visitation requires standard processes, definitions, and training. One of the outcomes that came out of that literature review was that there was a pretty large discrepancy in studies that involve digital mobility data between agency reports and academic journal articles. Specifically, most of those studies were showing up in academic journal articles, not in agency reports or agency protocols. And that really led to a recommendation for Fish and Wildlife in particular to consider using digital mobility data in their visitation estimation. We combine those interviews and the literature review into this comparability matrix, and the comparability matrix compares 18 methods across 30 different attributes. And what you're seeing here is just a small snippet of that matrix. The matrix is quite large and can't fit on the screen, but you can see a portion of the 18 methods there across the top. Things like surveys or vehicle counts or trail counters. And then here in the first column, you can see different attributes like overall accuracy and reliability, the requirement for conversion factors, probability of double counting, so on and so forth. And each of these cells are, although not displayed here, are footnoted with citations in the literature. So it's empirically backed here. It's a couple ways that we recommended managers use this for visitation estimation is horizontal scanning, where you might choose one attribute like the probability of double counting and figure out which methods might best or least match that attribute. And then vertical scanning, where you might look at one method like direct human observation and look at the cell assignment across a range of attributes. And of course, you can combine that vertical and horizontal scanning in order to evaluate several different methods at once or several attributes at once. This isn't a decision tree that tells managers what to do under what context, but it gives them concise information as a staff to make informed decisions about what estimation approaches to take and what might be some of those inherent trade-offs in that system. Coming out of that study, our third recommendation to Fish and Wildlife was to further consider and seriously entertain using some larger statistical models for visitation estimation nationwide across their refuge system, and specifically leveraging user-generated content and digital mobility data to do so. So let's jump in there. Digital mobility data is simply data that's captured as humans move through time and space. And so it's highly anonymized. It's very scalable. We can use digital mobility data in the scale of something like this room, but we can also use it nationwide or at a smaller scale, like across Clemson University's campus. It does provide almost real-time feedback, and it helps fill gaps where maybe traditional visitation monitoring techniques might fall short or are difficult to implement. All right, so y'all tell me, if I told you we had a whole bunch of data sources that come together and to build a digital mobility data set, and this digital mobility data has some kind of place and time associated with it, what kind of data do you think is being leveraged for these digital mobility data sets? Or specifically, what kind of like apps on your phone might be used by data providers to generate a digital mobility data set? Or what kind of things are out there fixed in society that might generate that data? What are your ideas?
Mobile phones.
What's that? Okay, and specifically, what about cell phones?
Navigation apps.
Okay, good, yeah, so Google Maps, those kind of things, Waze, what else? What other sources?
Photographs.
Okay, yeah, photographs posted online, excellent, good. What else?
Online web pages,
What's that?
online web pages or social media.
Yeah, excellent, good, very, very good. So social media kind of across various platforms, all right? And then what about things fixed out there in society that don't move, but might capture other things that are moving?
Security cameras?
Yeah, security cameras, traffic cameras, all of those kind of things. Excellent. Smart stoplights, all of that information. So all of that stuff gets combined and I'll talk about how that's aggregated here in a minute into large mobility data sets, billions of data points, right? And it's not just the things that we mentioned, but it's also things like citizen science projects, eBird checklists, also things like commercial shipping and commercial busing routes, commercial products that come from that, and then some stuff that's captured through camera traffic and cameras and those kind of things. So all these usual suspects, all that stuff gets rolled up into these large digital mobility data sets. And as you might imagine, there's quite a bit of market share associated with that. In 2024, for-profit digital mobility companies and vendors yielded about 260 billion in industry sales, so big industry, and they're projected to surpass that substantially for 2025. So big business here, right? This is big business. There are lots of companies out there now. There was less certainly a decade or so ago, but there are lots of these companies out there now really interested in making a profit and do so by all means. So let's take a look at one vendor here. The vendor that I'll show you is Placer AI. I'm not a spokesperson for Placer AI by any means, but let's just take a look at what one of those interfaces looks like. Let me get back to screen sharing. So this is Conestee Nature Preserve in Greenville. Anybody been to Conestee Nature Preserve? It's a great little spot right there. Okay, so a lot of these companies all have different interfaces, different dashboards, different mechanisms for downloading the data. But for Placer AI, you upload a shape file, or you can actually draw your boundaries in their interface if you want to. And then it gives you a whole bunch of choices about how you want to deal with the outcome metrics. Do you want the last 12 months or last 4 weeks or 7 days? And so you can segment that data however you want within their system. And we look at Conestee and say, okay, over the last 12 months, they appear to have 217,000 visits. The visit frequency looks like people are coming on average twice. Average dwell time when they're there, they're staying for about 31 minutes. And then there's just some basic graphs that help us understand some of that material. And then we can also peer into this and say, where were these people before and after their visit to Conistea? It looks like Quick Trip's getting some business out of Conistea there. And then there are some algorithms applied to that digital mobility data, which identifies the centroid of the zip code where that, in this case, for a cell phone and GPS are originating from. So you can get some kind of idea about the proportion of visitors that are coming from different zip codes. There's a bunch of other stuff in here too. I'm not going to go over it, but these companies kind of sell you on their dashboard function and the accuracy of their data. Okay, so how does this really work here? Well, you have all this data that gets rolled up into digital mobility data sets, gets purchased by these big vendors, these big data brokers. They have different contracts with all these different apps and cell phone providers and other sources of digital mobility data that you see here. And then they apply several statistical adjustments, fairly complicated and robust, to that data set in order to go through what they call normalization, which is just adjusting and parameterizing the model so that there is better representation from that digital mobility raw data in order to approximate the population that they're trying to capture. However, because it's for profit and proprietary, they don't disclose, at least in a transparent way that we would do in science and research, what that normalization process is. And they don't necessarily disclose or make it very transparent what all their digital mobility sources are. And that's because they're operating in a very different environment than us here in academia, in a competitive market space, and they don't want to disclose that material. However, it all gets rolled up into sales for these companies, and then it gets sold. And who do you think are the big buyers for digital mobility data sets? And I'll give you a hint, it's not the Park Solutions Lab. So who has the money to buy this at scale and would be really interested in where people are going, how often, and where they might be coming?
Google.
What's that?
Google.
Google?
Yes.
Not Google. Google's providing a lot of the information. They probably buy some of it too, but they're providing a lot of it. Think about who would be able to generate profit or more profit or ideally position themselves in a marketplace if they had information about where people were going, how long they were spending, and kind of who they are.
Advertisers?
Restaurants.
Yeah, advertisers, okay, good. Advertisers are a big one. Who else?
Facebook.
Okay, maybe Facebook.
Travel agencies.
Travel agencies, good. Yep. And real estate and big box stores and some government agencies. And then little old Park Solutions Lab over here. They show up to buy data and they're like, oh, you guys are cute. That's nice, right? And they put us in like a data social good, like whatever, reduced fee structure. And they're like, yeah, that's great. You guys love parks. You're so nice. But we're not the big players in that space. So we're talking about, big industry and people that use the data in order to increase profits. That's the majority of the industry. You might be thinking, well, I don't really want people to know where I'm bow hunting and where my favorite fishing spot is. And so the data goes through, it's highly anonymized. It goes through quite a process in order to anonymize the data. And the data is not presented in a form that an individual could be tracked. It's only presented and offered in an aggregate. And so it doesn't, you can't pinpoint a home location. There's certain locations, houses of worship and specialized clinics like Planned Parenthood clinics and other things like that that are not offered in the data set. And the industry, this is kind of the benefit of it being a for-profit industry. They realize that without clear anonymization there and robust anonymization, they may actually be killing their industry. And so they go through quite a process to make sure that it's anonymized. Another way that it's anonymized by some companies is due to the spatial aspect of the way that the data is presented. And sometimes you can get true point data, like vector data. You get the point and the timestamp, and I'll show you some of those examples. But often some companies will only sell it in kind of a larger spatial scale. And you can imagine on a hexagon or a regular data grid that this might say there's 35 people within that spatial area or 20 people in that spatial area. And then you can overlay that on a park or protected area in order to begin to understand what might be happening across that area or within a zone within that area. So what could go wrong? This sounds like a good idea, doesn't it? We've got all this data, we can go buy it, but what could go wrong? Or in other words, what are the threats to internal validity? Or what are the confounding variables that might influence the approximation of a population? What could go wrong?
If
Another-
someone doesn't use the app that that company is using to
Yeah.
get their location data.
Absolutely. So Onyx, right? Onyx Hunt. Majority of the US public isn't using that. They probably haven't even heard of it. Hunters certainly have. And so we would expect data derived from that kind of application would overrepresent the hunting population, a very small portion of society, and would lack representation in other areas. Good. What else? What else could go wrong? So we have representation issues. Stuff like we know that there's a certain age band that's on Facebook and a certain age band that's on Instagram and so on and so forth. So those again are representation issues, but what else might be a problem?
If there's service somewhere, if you're like somewhere where your app can't connect, so it doesn't know your phone's out there.
Okay, and so the data, that sometimes is a problem. The data is often uploaded later.
Okay.
So it batches it later, but that's good thinking. And in some cases, it does matter. What are some other problems other than the representation? Think about this example here of traffic cameras. What if that city decides to add 10 more traffic cameras or take away 10 traffic cameras? Right? They're not beholden to these for-profit companies to check with them to see if they can do that. They make those changes on their own. So in all of these data sources, there are internal changes that are happening. So really dynamic system, the way the algorithms work on social media, the way tracking may happen for commercial bus lines, all of that kind of stuff changes. So the whole system is dynamic. And that also influences the way that these things get rolled up and batched by these large vendors that are selling the data. Okay, so let's go to example here at North Inlet, Winyaw Bay. Anybody done research at North Inlet, Winyaw Bay? Okay, Clemson's got a good footprint there. It's near Georgetown and Murrells Inlet. It is an important area for biodiversity and ecological and coastal research. It has a lot of recreation research resources, and Clemson and University of South Carolina both have a footprint there in research institutes. We did a project there, really a larger visitor use project. It involved several components, surveys and interviews, but it did include some digital mobility aspects. And most of the research that's been conducted at the reserve has been through the physical sciences and mostly ecological research, and not a lot of visitor use research that's occurred there. So larger spatial scale, there's not like one gate that you go through or even one primary boat ramp. And so capturing and figuring out visitation there can be a challenge. And that might be a good application for digital mobility data. The information that I'll share here is from one company called Spectus. That's where we source the digital mobility data, mostly through cell phone location points. So here's some, this is just some point data that shows kind of density of use. And you can see that obviously we'd be able to compare things over time. We can run a bunch of spatial statistics on this and figure out what the degree of difference or the significance of clustering is. We can do all those things that you might normally do with your point data. But we can also do other things. We can determine, what the rate of return is. So what do return visits look like, and how is that segmented over the population? To help managers there further understand what's going on, we split this up by creeks, beach, and jetties and Windyaw Bay. So we zoned the area to align with some management functions, but also the reality of visitor use there. And then we can start to compare things like dwell time and stops over these different areas and make some comparisons across those zones. And then if we put those into a matrix, this is the average number of unique devices per day. We can say that it looks like the jetties are pretty busy on a Saturday. And then we can also do those kind of things by month and say that the jetties in particular are pretty busy during the month of July. So all that data becomes good information for managers. The conclusions from that project: high visits in the summer, few in the winter. Beaches had the lowest kind of visitation or unique devices. Saturday, high use, mostly late morning, early evening activities, but some late night activities going on there as well. And then most devices had between 1 and 4 return visits. All right, perfect. All right, buy the data, go to a place like Windyaw Bay. You're like, all right, here you go. Here's your number of visitors. This is what's going on, right? Not so fast, right? So here's the comparison between 2021 and 2024, same company, same data set, same analysis. And if we looked at that, we'd be like, wow, what happened at the reserve? People quit coming. Or we might say, wow, looks like there's a lot of repeat visitors going there as compared to 2021. But that's not really the case. There's another example, Clemson Forest, different data set. Visitation is kind of cruising along. This is from one particular zone there in the forest, cruising along, and then boom, it jumps up. So what's going on? Well, in the case of Windyaw Bay, back here, and in the case of Clemson Forest, the company changed some of its algorithms and its data sources in kind of unknown and untransparent ways. It was transparent to the company, but not to the people purchasing the data. And so we see these large changes that can occur across these data sets. And without monitoring the data and adjusting for those factors, you may very well misinform some of your results and implications stemming from the data. Now, the goal of ultimately of digital mobility data is not to just think about digital mobility data in a cross-sectional approach like the North Inlet Windyaw Bay National Estuarine Research Reserve, like one protected area. But, we start asking bigger questions, like, can we build a reliable visitation estimation model that would apply across an agency and all the units within the agency, or might apply across multiple agencies and all the units there? Can we have a reliable estimate, a reliable protocol for estimating visitation using digital mobility data? And so we began to explore that, and you can download this paper that we published this last year where we peered into wildlife refuges in particular. We began to answer that question. So can you build a larger visitation model using digital mobility data that will reliably estimate use across different refuges? So what did we do? Well, we took a whole bunch of digital mobility data. We had observed counts from counts that the Fish and Wildlife Service had been collecting for years in a sample of refuges. And then we also improved that with some of our own counts. And we did some comparisons between what was happening in the digital mobility data and what was happening at the refuges. The digital mobility data that we accessed specifically for this project were Flickr photos, Twitter posts, Instagram photos, all trail reports, eBird checklists from eBird, and then we used 2 different mobile data sets, one from a company called AirSage and one from Spectus. And then we went out and did on-site counts. The Fish and Wildlife Service had already been counting at their sites, but we went out and helped them improve it to make sure that we had the most reliable field estimates possible. And we used some of that then to adjust their previous calculations that they had field counts on prior to this study. And so we ended up with the most robust field counts possible. And then the question is matching, how do we match the digital mobility data to field counts? And you'll see here that once we start to look at these sampled refuges, and then we start to look at the different sources of digital mobility data, that the accuracy in this notion, the correlation varies by data source, but also by refuge. And we can see that these different digital mobility sources have different correlations depending on refuge. And some of them are quite good, and some of them are not so good, but pretty high variation in there. And then another way to look at that is to just peer directly into the data from the digital mobility companies, and you can, or from the internet sources, and we can say that, wow, these are really different estimates for the same locations and the same times. So we did some dominance analysis. We know that all these things, there's some linearity between all of these sources. We did a dominance analysis. And what we found was that, and not surprisingly, the model that worked the best, that had predicted the most variability or accounted for the most variability, was this combined model where we were able to combine multiple digital mobility data sources and then add a fixed effect of refuge in order to account for unique characteristics at each refuge. And that ended up predicting visitation rather well. About 92% of the variability in visitation was captured by that model. Now that model, and what you're not seeing on the screen here or the previous screen, is quite a bit of dealing with different parameter estimates and adjusting those and weighting them throughout the process in order to get the model to be the best predictor. So a large kind of iterative process of developing that model. However, it's not without its challenges, right? So mobile products change over time in unexplained and unexpected ways. So this is one company, AirSage, where we purchased data from, and you're looking at 2020 and 2023. So we bought a data set in 2020, we bought another data set in 2023, and you can see, even though it's the same company, their estimates are quite different because something changed in the way they were sourcing data, normalizing data in 2023. And then another way to look at this is two different companies. Mobile provider one is Spectus, mobile provider two is AirSage. And those two companies, different structures, their data looks different. Right? So the implication is that we can't use any of this stuff out of the box without calibrating it with some field counts and without doing some careful adjustments there as well. So what are some of the key takeaways? Well, from that study, digital mobility data can definitely add value when it's calibrated appropriately. The multiple source models are going to provide the best prediction. Probably not a surprise, but those multiple source models also have to be tweaked and parameterized in a way that yields the best estimates. And then refuge level context is essential for accurate estimates. So it's difficult to get the model to fit well without incorporating context. And the way that was done was, you can think about infrastructure at a refuge. Some have boat ramps, some don't, some have trails, some don't. So this presence and absence of specific infrastructure allows us to build an index, which allows us to capture some of that refuge level effects. So ultimately, there's promise, but there's also limitations here for thinking about digital mobility data as a mechanism for visitation estimation. So what are the big take-home kind of message here? Well, digital mobility data is good, but it needs to be used alongside traditional counts. We're probably not at a spot, and I don't think we'll be there in the next couple of years where we can just kind of out of the box use digital mobility data or large visitation models alone to predict visitation. We're getting closer and closer, but we still need those traditional counts. And we certainly need those traditional counts just to parameterize the model and to understand the accuracy of that model itself. But it's a bit of a recursive system, right? The better the field counts are, the better that estimate is for matching it to the model. And so the field counts really matter. Digital mobility data probably holds the greatest promise for these large and porous, low-staffed areas where visitation estimation is extremely difficult. If we can figure out a good visitation model for in-sample spots and then indicate that there's some reliance on that model for out-of-sample spots, that would really help these large, porous, protected areas. Integrating visitor data with the ecological monitoring, so some of those density maps and other things I was showing, you can imagine overlaying that with a variety of other layers to figure out where people are going and how long they're spending, which might be in or near or on sensitive wildlife habitat or other sensitive ecological resources. And then probably not news to you guys, but partnering with managers in this process is really, really important. When we did our sample spots with Fish and Wildlife, we were on site helping them improve counts, but we also used that as a training for those managers there at different refuges to improve their estimation system. And in turn, they were willing to share more and more of their data and more of some of the problems with that data as well. But that connection with managers and building a visitation model was just critically important. So the ultimate goal here, right? The ultimate goal is to labs like the Park Solutions Lab and other labs across the country are working in collaboration to figure out how we can best create a model that kind of ramps up that second study that I presented from Fish and Wildlife Service. How can we get a model that really reliably predicts visitation across all protected areas? That would be the vision. Across all protected areas and across all agencies. And indeed, federal land management agencies are very interested in that. And you can imagine why. It would decrease staff and labor costs out in the field. It would increase potentially the consistency in monitoring. It would provide more real-time estimates as opposed to having to wait a whole year in order to understand visitation at a refuge. And so there's a lot of interested parties in that, but we're not quite there. And we're not quite there for the reasons that I've highlighted today. Changes in for-profit structures and the digital mobility data companies, changes in the way that that data is sourced, changes in the sources of those data themselves, like Facebook or Google and all of those kind of things. But there's some other things we can do before we're reaching that vision, and we've landed there. Things like cross-vendor comparisons. Comparing a variety of vendors, let's say you buy data from 10 different companies, comparing the performance of that data across those vendors. Those are things that haven't been done to scale, but they're certainly out there for interesting research questions. There also hasn't been, because of the proprietary nature of digital mobility companies that are selling this data, there hasn't been a deep dive into standardizing the protocols. A lot of times those protocols are not fully shared, but if somebody was to gain access to those protocols, it would be an interesting comparison to see how different or similar those protocols are and moving towards some kind of standardization of best practices. And some of that work has not been done either. We talked a little bit about linking the visitor data or the visitation data with ecological outcomes. I think there's, especially for this group, that's a ripe area to study and quite a bit of unanswered research questions in that area. There's still some concerns about privacy, equity, and representation concerns. I personally don't think that digital mobility data is going away. I think it's the kind of thing that's going to continue to be used and ramped up, but we have seen Europe and the EU really kind of clamp down on the way that that data can be used. And I can imagine a time in the US where we might see some larger sidewalls put on the way that data is sourced and used in the United States. And then, of course, training the next generation of scholars in digital mobility data, data science, and conservation approaches. What I'm talking about to you today might seem like, oh, wow, I've heard of this before, but I didn't know a lot about it. I would imagine in about 10 years, most everybody in the room will have said, oh yeah, I've worked with that data. I understand what it is and its shortcomings and what it looks like. And so I see this as something that's going to be around for some time, and probably the responsibility of the educators in the room, including yourselves as grad students. It'll be our job to help train other people in how to use and integrate this data, with also being very real about the shortcomings in that data as well. So y'all have probably heard the term "don't go swimming alone," and research is a team sport, and this certainly was. Everything I presented today is not just a representation of stuff that I've done. It's a big team over at University of Washington, and then folks at North Inlet and Fish and Wildlife Service as well, and then several collaborators here at Clemson University. And I think big data takes a team approach. And, you know, you're talking about a whole bunch of different skill sets that need to be applied to this. And so assembling a team to do so is a really important aspect. So where have we been? We talked about visitation estimation, what it is, why it's challenging, what does the literature say about it, what would a manager say about it. We talked about digital mobility data. What is it? How's it sourced? Where does it come from? What are the problems with it? And then looked at our 2 study sites, North Inlet, Fish and Wildlife, talked about some practical recommendations, future research directions, and here's our conclusion. So the big take-home messages for the day, just like a pastor at church, I got 3 points, right? So visitor estimation is foundational but challenging. Digital mobility data can add value when calibrated and integrated. And then this collaboration between managers, researchers, and students is key to success. That's it. I wanted to leave enough time for us to talk through this. And I'm really interested to hear from y'all how you could see, even if it's hypothetical, how you could see using some of this data in the work that you're doing.
Questions?
I had a question, like, so if you take, for example, like out west where there's a lot of public land and you don't technically really have the like hard data of counting people that come in and out of public land. What limitations does like signal strength from phones offer for like estimating these populations? If you don't have signal, does that offer a huge limitation in this data, or using digital mobility? How does that work?
It's a great question, and it does offer some limitations, but particularly in real time. So if we're wanting to know that particular day what's going on, or that particular hour, like a smart traffic counter that's satellite connected or something like that, you're not going to have that ability with digital mobility. But all that information, let's say you're using Google Maps or Onyx Hunt or whatever your app you're using to navigate around in a protected area. You're out there taking pictures of whatever, a certain plant, and you're trying to identify it on an app. All that information that's geolocated is going to get uploaded later. It might be when you get back to the ranger station and you have Wi-Fi, or when you get to a hotel or an Airbnb. All that's going to get uploaded later and get batched. And so you'll see these digital mobility companies that a lot of times they won't give you real-time estimates. It'll take a few days of a lag, and that's because they're waiting for some of that information to get uploaded and batched up. And we've used digital mobility data in a lot of remote locations. I mean, as remote as like Katmai National Park in Alaska. So the classic, right? The classic picture of the Alaska brown bear on a waterfall. catching a salmon in its mouth. Like 95% of those pictures are from Brooks Falls at Katmai National Park, but it's super remote, no roads, fly in only. John's been there. And we've used digital mobility data there, and it does not work as well as a place like Conisty, which is pinned up against a major metropolitan area. So we do see some differences in the model performance and just the ability of the digital mobility data alone in more remote areas. And in fact, that's where we need to use it probably most, right? So this kind of this difficult problem to resolve. Yeah, good question about access. Good.
Building on the same area, like at this stage, it's still it's still a novel approach, right? So do you suggest that this data, like digital mobility data, be incorporated in the analysis part, or just be left for educated inference? Or
Yeah, so to the extent that an out of sample location has similar characteristics to the refuges we use for the sample, then we feel pretty good about extending that to those areas. Now, and so let me paint that picture, right? If you have a refuge that has, let's say, really low visitation, like 20,000 visitors a year, no roads, only accessed by boat, coming from a whole bunch of different access locations, it may not work as well because that wasn't the characteristic of the refuges that we sampled. We tended to sample refuges that had higher visitation, had roads, had trails, other things like that. And so that typology, or the characteristics of the sampled spots, going back to that refuge level effect, really matter for how well you can transport a visitation model from one location and apply it in another location. And so I guess the answer is yes and no. I would feel really confident if the characteristics of an out of sample refuge match the characteristics of the in sample refuges. But if it was drastically different, we would expect the model to probably not perform as well. And that also highlights the challenge of trying to scale this thing and go from this ultimate question or goal: can you create a visitation model based on digital mobility data that's applicable across a wide range of protected areas and agencies? Good question.
What's the ballpark for the cost of the data?
That's good. I was hoping somebody was gonna ask that. Good job, John. So the cost, so when all this started, whatever, a decade ago or a little bit more, we had people coming to us and they're like, hey, can you use this data? Like, we'll just give it to you. You use it, see if it, if you have uses for it, maybe write like a little free pager on how you used it and how it was useful and stuff like that. Well, those companies aren't showing up and knocking at our door anymore. We're showing up and knocking at their door. And we've used probably 10 or 15 different companies, and all of them, the first approach is you meet with their sales team. So you're not meeting with their data scientists or their data engineers, as they're called. You meet with a sales team, and that sales team clearly is trying to sell you on the reliability and accuracy of their data and the ease of use of their dashboard. That's the sales pitch. So they're selling you on that. They give you a demo. You can ask for data. We've done that. They give us a little data. We come back and we're like, look, it doesn't match these field estimates. And then they get a data engineer involved and kind of explain it away. And so all these companies kind of have that same approach. And that's not to demonize these companies. It's just that they're a for-profit company. They're selling the data. So it used to be that we could buy like a whole year's worth of data for a protected area for like $500. Pretty awesome. I'm like, you know what? We can buy all kinds of data. We'll do that. Now that Placer AI that I showed you guys, the price tag on that is about $45,000 a year. And that gets you like 3 or 4 different logins that you can have associated with that. So a lot of money. but it does have unlimited data queries. So we can search any kind of spot we want. We can do that. It's kind of unlimited access. The pricing is interesting only because all of these companies have like, it's like selling anything else, right? They have all these different models of what you can buy. Think about going to buy a car, and you can get like a baseline model, or you can get like the primo model and everything in between. And if you want to add this feature, you can do that, but it's going to cost you this much. And it's going to come with these other 3 features you don't really need. So all of these companies have some kind of system. And then they have all these other packages. They're like, oh, you want that package? Well, this is going to cost extra. So it really depends on the pricing structure. And part of that's driven by folks with much deeper pockets than the Park Solutions Lab or other labs at Clemson University. I can imagine a time, though, when Clemson or other similar institutions would do an enterprise license with one of these vendors. And I think that's probably the next step for accessing this kind of data. So we're not all doing it individually. The way we've handled that, the 45,000 is a little beyond our budget annually for a Park Solutions Lab, because we're doing many other things other than dealing with digital mobility data. And so we have combined several labs in our department. Everybody pitches in and gets access to that data. That's what we're doing. Yeah, good questions.
One question online. Jacob, can you unmute or?
Yeah, great talk. I really enjoyed it. I was just wondering how much interest the Can you hear me?
All right, Jacob.
Hello? Can you hear me?
Loud and clear, man.
Okay. Great talk. I really enjoyed it. I was just wondering how interested the public is in just seeing these types of data, if at all, and in your experience, how willing the public is to help in the collection of this data. I know a lot of it's digital, but with maybe more direct methods like personal interviews and stuff like that, like what are you seeing when you perform those methods?
Yeah, it's a great question. You know, I did see a few things. I have seen an increasing number of a few things on TV of just like, oh, look at like this, whatever, visualization of a heat map of people going into the Super Bowl and out of the Super Bowl and the traffic patterns and all of those kind of things. Now, I'm a professor nerd, so I see that and I'm like, oh, that's cool, right? Now, I don't think I'm representative of the rest of the public, perhaps, and so maybe not everybody else thinks that's interesting. But you bring up a good point, and one that we recently highlighted in an article is that the potential, what we've seen over the years through empirical studies, is that visitors to parks and protected areas are more than willing to help out. Right? They're there because they love those areas. They're there because a lot of times they want to give back to those areas. And when they're asked to do so, they often contribute. And that this provides an opportunity for visitors to do that. So for example, you can imagine if you asked visitors to complete a survey question when they entered a certain parking lot and it pinged them, it was a geolocated survey question, it pinged them on their phone, they would be willing to do those kind of things. And all of that would add to the accuracy of digital mobility data sets. And so there is an opportunity, I think, through the National Park Service app, right? There's an app for every park, for the Park Service, and you can bring up any park within that. Well, they can begin to, these agencies can begin to capture their own digital mobility data as well, which would be very site specific and would allow them to tailor what data is being collected, how it's being organized and batched, which might be much more salient for that particular agency as opposed to something else. And then if you encourage visitors, to your question, Jacob, if you encourage visitors to download and use that app and you let them know that it was improving visitor experiences and data for park management decisions, they would probably be willing to do that. That's a good question.
Great, well, that's all the time we have for today, but thank Matt again for coming to talk.
Do something fun this weekend with your sticker. Take a picture of it, put it on Instagram, and your data will be purchased by somebody.
Yep.